Good day everyone. In this episode, we are going to have Mathematics Grade 8. This is the part 2 of Operations and Rational Expressions in addition and subtraction of rational expressions. I divided this topic into two categories. One is addition and subtraction of rational expressions with like denominators and unlike denominators. For this episode, we are going to have addition and subtraction of rational expressions with unlike denominator. You can watch the addition and subtraction of rational expressions with like denominator in other video presentation. Moving on to the steps in addition and subtraction of rational expressions with different denominators. First step, find the least common denominator or the LCD. Second, write the equivalent expression of each rational expressions. Third, add or subtract the numerators and keep the LCD. And the last one, simplify your answer if possible. How to find the LCD? List the different denominators that appear in the rational expression. Second, factor each denominator completely. Third, for each unique factor, compare the number of times it appears in each factorization. Write a factored form that includes each factor, the greatest number of times it appears in the denominator factorizations. Moving on to our first example, 5m over 2n minus 3n over 4m. Find the LCD, that is the first step. So 2n, factors of 2n are 2 and n. Factors of 4m, we have 2 times m. Make sure to align same numbers and same variables to be able to find the LCD. Simplifying, we have 2 times m times n. Therefore, the LCD of 5m over 2n minus 3n over 4m is equal to 4mn. Next step, change each fraction to LCD. So to be able to align the denominator to the LCD, you have to multiply the first fraction to 2m and the second fraction to n. Simplifying, we have 5m times 2m is equal to 2m squared over 2n times 2m is equal to 4mn minus 3n times n is equal to 3n squared over 4m times n is equal to 4mn. Adding and subtracting the numerators. So 2m squared minus 3n over 4mn. This is now the simplified answer in subtracting 5m over 2n and 3n over 4m. For our second example, we have 7 over x plus 3 plus 4x over x plus 6. First step is to identify the LCD. So x plus 3, the factor is x plus 3. X plus 6, the factor is x plus 6. Therefore, the LCD of 7 over x plus 3 and 4x over x plus 6 is equal to x plus 3 times the quantity of x plus 6. Second step, change each fraction to the LCD. So what are you going to multiply so that the first rational expression will change into the LCD? So you are going to multiply that by x plus 6. And for the second rational expression, you have to multiply that by x plus 3. So simplifying, we have 7x plus 42 plus 4x squared plus 12x. How? 7 times x is equal to 7x. 7 times 6 is equal to 42 plus 4x times x is equal to 4x squared plus 4x times 3 is equal to 12x. Retaining the LCD over x plus 3 times the quantity of x plus 6. Simplifying our answer, 4x squared plus 19x plus 42 over the quantity of x plus 3 times the quantity of x plus 6. The numerator isn't factorable. Third example, 2 minus 1 over x plus 1. Finding the LCD, the denominator of 2 is 1, therefore its factor is 1. Second, x plus 1, its factor is x plus 1. Therefore, the LCD of 2 and 1 over x plus 1 is equal to x plus 1. Changing each fraction to LCD, multiplying 2 by x plus 1 minus 1 over x plus 1. X plus 1 is already the LCD, so there's no need to change. Simplifying, we have 2 times x is equal to 2x plus 2 times 1 is equal to 2 minus 1. Retaining the denominator or the LCD, x plus 1. Simplifying our answer, 2x plus 2 minus 1 is equal to 2x plus 1 over x plus 1. Let us now recall the steps in addition and subtraction of rational expressions with different denominators. First, find the least common denominator or the LCD. Second, is to write the equivalent expression of each rational expressions. Third, add or subtract the numerators and keep the LCD. And the last one, simplify your answer, if possible. How to find the LCD? List the different denominators that appear in the rational expression. Second, factor each denominator completely. Third, for each unique factor, compare the number of times it appears in each factorization. Write a factored form that includes each factor the greatest number of times it appears in the denominator factorizations. I hope you learned something from this episode. Thank you for watching.